This is my second part of the Perceptron example. So in the first part, we simplified the initial data, made train and test subsets, then on step number 3, prepared simplified formula parts like x, x, y, y, created coefficients w, w, and then we started with the first row of data and calculated results of formula of linear equation zz, then made an activation, made variable pp, and then finally made a dd, which is how to update our coefficients. Then I applied the same algorithm to the row number 11 to show how coefficients will change if prediction went wrong. Okay, and now my goal is to go and automatize the process to make our 30 rows in one automatic process. This is possible, of course, but you need to learn how to make a cycle. So cycle is a thing which will repeat the stuff some number of times. So let us do the cycle, and to make a cycle we need to create numbers of rows. So our data xx has 30 rows, so we need to create 30 numbers from 1 to 30. It may be done in multiple ways. I prefer more universal way, so I will run sec underscore along yy, which is our species 0 or 1, setosa or non-setosa. These are 30 numbers. Then I will use these numbers to build a cycle. So our cycle will start with operator for, and then we need a parenthesis, and we need to create some kind of temporary variable. Typically it's called like I. In is the reserved word, and then we need that sec along yy. So I will be 1, then 2, then 3, then 4, then 5, then 6, and so on. Then first time in my R lessons, I think we use this curved brace. So everything which is within a cycle will be within these curved brackets or braces. So when I open it, you will see that the R will show me the plus as a prompt. So now I will make these 4 things like ZZ, PP, DD, and updating of the coefficients. So I will simply use my arrow up to simplify my life. ZZ, but instead of 11, I need I, because it will be 1, then 2, then 3, at some point it will be 11, and finally will be 30, it will be last cycle. Okay, so it will take row number I and will calculate ZZ from that row by multiplication and summarizing with coefficients. Then it will calculate result of activation, PP. I don't need to change anything, it's straightforward. Then it will make the difference to update coefficients, which I call DD. Again, I need to replace this 11 with I. And finally, it will update our coefficients. Again, I remind you that if yy minus pp is 0, then update will not happen. That will be case if prediction went correctly. If prediction went wrong, like in our row number 11, then some update will happen. WW will be result of WW plus DD. Alright, and then I will close my brace, and when I type enter, this cycle will run 30 times. Done. So now we have probably different coefficients. Let me type it. WW. Yes, of course, quite different. So my idea now, we need to repeat this cycle multiple times until our coefficient will stop to change. So it's again a bit boring, but much less boring if we would do it like for each of 30 rows and again multiple times of that. So this one, the Z1, PP1, the D1, and finally WW will be updated, and we close the brace and look on the coefficients. It's different again. Let us do it again. Again ZZ, again PP, again DD, again WW update. We close our brace and look on coefficients. Different again, so we need it again. 1, 2, 3. So each time I type arrow up on my keyboard, DD, WW update, close brace, WW, again different. So try it again. So sometimes you need to try multiple times, like 10 maybe, but sometimes this training process will converge faster. So yes, what will we hope to see is a convergence. This is a situation when coefficients will stop to change. Update it, close brace. Whew, this is it. Look, so now our coefficients are the same as in the previous step. So that we called convergent. Okay, so that is our training of our model, and I hope it is done. Now we need to understand how well this training went. So we need new step. I call it step 11. So step 11, we'll try to check it with a table, the same table as we applied to the previous machine learning examples, misclassification table. So first of all, I will take my final coefficients, which is 4.8 minus 8.8 and 3.0, and use it as the same formula as we did before. So I will simply repeat ZZ, but instead of I will have an empty space, which means what? I will apply it to the whole column. So it will, R has a very powerful mechanism to apply stuff to the big sets of numbers. So this is how I calculate ZZ right now. Okay, and now my ZZ is a different thing. So let me just a set of 30 numbers. And then I need an activation, PP. And PP is a set of 30 ones and zeros. And finally, I'll make a table. Actually, I already see that result of is similar to what I had in my YY variable, but let us check. Wonderful. So you see that 20 of non-setosa predicted as non-setosa and 10 of setosa predicted as setosa. Perfect results. But don't forget, this is a training data set. Now I will use the same logic to our test data set because the model is ready. Our model are simply these three numbers. This is our model. So we apply it now to our testing data set. So I will do the same approach to understand how it works. So I will use new variables xxx, which will be morphometric part of testing subset, iris2 test, first two variables, and then YYY, which is just the last species variable of testing subset. Okay. And then I will apply the same ZZ calculations, but replace XX with XXX. And I didn't change coefficients. They are done. And we'll call it like ZZZ for convenience. Okay. Now I will make my activation the same way as we did before. So only to replace letters ZZ to ZZZ, and PPP will call result. Finally, the acid test. I will need to make a table from our real species, Setosa or non-Setosa, and predicted species. Absolutely marvelous. You see that out of 80 non-Setosa, only one was predicted wrongly, and out of 40 Setosa, remember that testing subset had 120 rows, 40 Setosa all were predicted as one, as Setosa. So this is how neural network, in our case actually simple neuron, Perceptron, learned to recognize iris species. How it did it? So that sounds like magic, but the answer is simple. So it is a mechanism of updating coefficients. Each time when prediction went wrong, coefficients were updated in relation to the actual data. So that's an answer. That's how Perceptron works. Each time when everything is wrong, it will update it slightly, change coefficients, and see if it's better. And we repeated this 30 row sequences multiple times. So actually, how many times we did it? So we did it first time, the second time, the third time, the fourth time, and on our fifth time, coefficients start to be the same. So that was convergence, and we decided to stop here. So 4 to 30, 120 times we repeated that learning process and found some 3 numbers which allow us to calculate species from 2 variables, 2 morphometric variables which we used. These morphometric variables, just to repeat, are sepal lengths and petal lengths. By the way, not the best variables, but quite efficient ones, especially petal lengths. So they allow to understand species. If we look on them, the actual miracle, which I hope to be explained, is that system learned it itself without any participation of any hints from our side. So this is how neural network works. There were a lot of simplifications today, and I tried to avoid as many terms as possible and simplify everything, but if you got the principle, you will probably start to understand better how neural networks working. So thank you.